Hello and welcome back to our channel. So this is a continuation of our Python series where lastly we saw how to handle VS Code with the extensions and all the required setup to run our Python code. So in today's tutorial we are going to talk about Python variables. So we are going to learn how to store, name and use data in Python. Remember that data is one of the most crucial aspects when it comes to programming because we are going to handle a lot of data. For example, user input, even data within the program itself as it's executing. So you have to learn very well how to use variables in order to handle everything. So let's dive into it. So, what are variables? So, a variable is a container or a store for storing data. So, we are going to look at a variable as a bag that contains your book. So, if you want to make everything organized, you get all your books, then you pack them into the bag. So, when somebody asks you where are your books, you will be referring to that bag that my books are that side. So, a variable is like a container. For example, you have a variable then remember we've said it's a container, so consider it to be this box. Then inside that variable you can put some specific data or specified data of your interest, and this could be any data type inside like a string, an integer, a float, etc. Very many. So it depends on what you really want. Then you could be having something like a variable. Remember, variables will always verify. We shall always reference them to as variable names. So when you create a variable, you give it a name. So that's why I'm having here variable name. Then the equal sign will be called an assignment operator. So I'm having a variable name being assigned to 10. This implies that I'm having 10 being stored within that variable. So at most time, a variable names will always be our reference points for a specific piece of data in our program. So what do I mean by a reference point? For example, in case you want to access 10, instead of hard coding the 10, you have to call its variable name. So you reference to that variable name, assuming that you wanted to add maybe a 4 to that 10 to make it 14. Instead of getting 10 plus 4 to get 14, you just call the variable name your reference point, then you add that 4 to give you a 14. So it behaves as the value it contains. So you will find out that the variable you've created or that variable name, when you try to reference it, it will have all the properties of that data stored in. Then let us talk about why we use variables. So one of the reasons why we use variables is to store data for later use. So remember, we are designing programs and those programs can take in a lot of data. So if I'm interested in storing data for future use, for example, maybe the process was running, then it generated some maybe data or information. I would like to store it somewhere. Then I use it, even I can display it to the user. So you find out that I have to use variables to handle that situation. Then number two is to make the code readable and reusable. So when I talk of readable, it's like you organize it. Remember, I gave you an analogy of a bag whereby you put all your books there so that you organize it. So that now when you talk of variables, it's like you get a central point where you can control your data from. And being reusable, this implies that you can call that variable name everywhere you're interested in calling that data you stored into that. Then the other thing is the dynamic nature of variables. We have talked of program execution, so you will find out that during the program execution, many of the data will change inside our program. So variables can easily keep track of the changing data within the programs. Then we have memory efficiency. Reason being, when we talk of memory efficiency, that means I'll call it the space complexity of our program, as in how much space will it take to run, as in memory. Maybe it will take around maybe 10 kbs. So when you write code, you have to make sure that you utilize the memory of your computer so that you take little or less memory during execution to make the programs more fast and more efficient. So we are going to look at that memory efficiency when it comes to real coding, as we are going to see. Then number last is flexibility. So when I talk of flexibility, this implies that I'm talking of the how variables can easily change so they can adapt to any environment. So if you are developing a program that can easily adapt to any environment, it's all about you better use variables. Reason being they can easily be converted from one data type to another without having any complications within your program. Then let's talk about declaring variables. So in Python, you don't need to declare data types as you see in other languages like C. So in Python, you don't need to declare because Python is a dynamically typed language. So you just assign a value you want to store to a variable. So when I talk of a dynamically typed language, I mean that it's a programming language where you don't need to declare the data type of a variable when creating it. So you don't need to tell the computer that, do you know what? I'm creating maybe a string and I'm storing their name. All I'm creating maybe this is an integer variable and I want to store there, for example, age. So you don't need to tell the computer. So the data type is determined automatically at runtime. So the computer will know it automatically. When the program is being run, it will have to recognize the different variables within that program. For example, you don't specifically tell the computer in advance. You just say the variable, it will be determined at runtime. For example, when I talk of a dynamic type language, look at this age being assigned to 20. So there is nowhere where we think that 10 maybe is an integer or a float. So it's just age. Now when it comes to the other opposite, which is a statically typed variables, you'll find out that you have to tell the computer that this is an int. Specifically, you have to alert it. So when you say that int age, then you assign a value 10. This implies that the variable age is storing 20 as an integer. So you tell the computer that, you know what, I want an integer stored in this container because we're talking of variables as containers or stores. So the general syntax for declaring variable is very simple. First of all, you create a variable name. Then you put the equal sign, so we shall call that one an assignment operator. So in this case, it won't be the equal sign. It will be what we call the assignment operator, as we are going to see. Then you assign a value to it. So when we talk of a variable name, it can be a word or a letter as long as it follows the rules as we are going to see in the next slide. Then the equal sign, we shall call it an assignment operator, and the value can be data type of any kind like a string, an integer. So it depends on really what you need to store in that case. So if you are to that statement variable being assigned to the value, it will be something like the variable becomes the value. So here is some of the examples of some of the variables you can create. For example, age being assigned to 20, then name being assigned to forge, and subscribe being assigned true. Now let us talk about the rules for naming a variable. So there are quite many in a number. So let's start. Rule number one, all variables must start with a letter or an underscore. So for example, it could be age being assigned to 20 or underscore name being assigned to 40. So make sure that all your variable names always do start with either a letter or an underscore. Then number two is variables cannot start with a number. So you cannot have something like this. Maybe one name being assigned to 40. That's wrong. So when you try running it, the Python interpreter will throw an error. So it will inform you that this variable name is invalid. Then number three is variables can only contain letters, numbers, and underscores. So there is nothing more that you can add to variable names. This implies that any use of special characters like the percentages, dollar signs, all the art, or all these ones that are on the last line, for example, the question mark, the slashes, they are invalid. So when you use them within your variable name, you'll get an error. Then the other thing is variables are case sensitive. This implies that name that starts with capital N is not equivalent to name that starts with a small n. So you'll find out that there will be totally different variables, or they will store data differently. This implies that the name with a small n doesn't conflict with a name with a capital N. Then the other thing is you cannot use reserved keywords when you're creating variables. So this implies that you have to be careful. So when I talk of the reserved keywords, I'm like words that have special meaning in programming. So they are already known by the programming language or the interpreter that these ones do perform a special action or a special activity within the flow of the code. So when you use them as your variables, you'll get an error. For example, has, if, while, else. There are very many, there are around 32, but don't worry, we shall cover all of them and you will learn and master how to use each and every case in this scenario. Then the other thing is variable names should have no spaces. So no spaces in variable names. This implies that you can't have something like first, then you space it with first, then space, name being assigned to Forge. That's wrong. So there comes in a convention whereby you have to write something like first underscore then name being assigned to Forge. And this is called the snake case. So there are very many, but in Python we normally adapt to the snake case. Then the last thing is not even a rule, but it's best practice. Use meaningful names when you're creating variables. For example, if you write x being assigned to Forge, that's right and it's true. But assuming that it's a very, very big program around 1,000 lines of code, after a month when you code back to revisit your code, can you really tell us that x had stored a name? So it would be better if somebody had used name being assigned to Forge. So, lastly, let's talk about how we assign values to variables. Remember, we've already seen that you could do something like age being assigned to 10. So, this implies that age becomes 10. All name being assigned Forge. And this would imply that the name becomes Forge. But in real sense, or in real practice, this is just a single assignment. So, you're having a single variable name being assigned to only one value. Now, we can have what we call the multiple assignments in Python. For example, I could have something like A, comma, B, comma, C being assigned to 10, 20, and 30. This implies that in this case, A will be equivalent to 10, then B will be equivalent to 20, and C will be equivalent to 30 as we are going to see in practice. Then there is something like maybe when you want to have different variables but with the same values. You could be having something like x being assigned to y, still being assigned to z, and being assigned to 0. This implies that x, y, and z are all having the same value, which is 0. So now, let's dive into the coding and we see actually how we can implement all the ideas we have talked about in this theory.